Last time we spoke about Johannes Kepler. Galileo was alive at the time of Kepler, but largely ignored him. Today we're going to look into Galileo's life and the controversy between Galileo and the Church. Italy was not yet a unified country at the time of Galileo, but the Italian peninsula was well recognized. Galileo was born in Pisa in 1564, the first of 6 children, 4 of whom survived infancy, in a musical family. His father played the lute. His family moved to Florence when he was 8. In 1580, Galileo began studying medicine at the University of Pisa, but he later convinced his father to let him study mathematics and natural philosophy. In 1586, Galileo published a small book on the design of the hydrostatic balance he had invented. He applied to be the chair of mathematics at the University of Bologna, but he was not accepted to that position. The following year, in 1589, he was appointed to the chair of mathematics at the University of Pisa. In 1591, his father Vincenzo died, so he had to make sure he could make enough money for his family. So the following year, in 1592, he moved to the University of Padua, where he taught geometry, mechanics, and astronomy until 1610. In Padua, he did experiments with pendulums, falling bodies, and sound frequency. Galileo was the first one to say that in a vacuum, 2 bodies of different mass will fall at the same rate and hit the ground at the same time. This experiment was done on the moon. Of course, the moon isn't a vacuum either, but there's a lot less atmosphere there, less air resistance. There's a legend that Galileo dropped objects from the Leaning Tower of Pisa. This is probably not true, but he may have dropped objects from a church bell tower to experiment with falling bodies there. Galileo also had a notion of relativity before Einstein. In Galilean relativity, the laws of physics are the same in any system that is moving at a constant speed in a straight line, so there is no absolute motion or rest. There's a tale he experimented with this by tossing keys on a boat that was moving through a lake. Galileo had 3 children out of wedlock with Marina Gamba in 1600, 1601, and 1606. In 1605, the year after Kepler's supernova, Galileo received a letter from Ottavio Brenzoni about Tycho supernova and a lesser nova in 1601. And Galileo concluded that because they did not display diurnal parallax, they were distant stars, and thus disproved the Aristotelian belief in the immutability of the heavens. So especially from that point on, Galileo was convinced of heliocentrism. At that point, he intended to keep this idea quiet. But after his discoveries in 1609 and 1610, he wanted to share this with everyone. Galileo didn't invent the telescope, but right at the time when they were being invented, he built one. His first telescope had a 3 times magnification. He later made an improved version with up to 30 times magnification. So if you look through a good pair of binoculars, you'll see similar things to what Galileo first saw through a telescope. He observed the moon and how it has mountains and valleys and craters. He observed stars that are too dim to be seen with the naked eye. Scanning through the Milky Way, he realized it's not just a nebula, but there are many, many small stars. Most significantly, in early 1610, he observed the moons of Jupiter. He wanted to name these after the Medici family, his patrons, so he called them the Medicean stars. But someone else who had discovered these moons of Jupiter around the same time but didn't publish his results had called them Io, Europa, Ganymede, and Callisto. So those are the names we know them by today. By observing them on several nights, he realized they were not orbiting the Earth, but they were orbiting Jupiter. So this was big news. Not everything has a common center. There are multiple centers. That's what Copernicus said. Galileo's observations of the moons of Jupiter were confirmed at the observatory of Christopher Clavius, who was the most prominent astronomer of that day. Christopher Clavius had picked up from Luigi Galileo's calculations for the Gregorian calendar. Christopher Clavius finished those. He was a Jesuit, and so he was recognized by all the Jesuits and pretty much all of Europe in that day as the most prominent astronomer. Clavius was old at the time, and in fact, he passed away in 1612. But because the observations of the moons of Jupiter were confirmed at Christopher Clavius's observatory, Galileo received a hero's welcome when he visited Rome the next year. Galileo also observed the phases of Venus, both crescent and gibbous phases, which were impossible in the Ptolemaic model. It wasn't conclusive evidence for the heliocentric model. Tycho's compromise model and other geo-heliocentric models could still be possible, but it at least disproved Ptolemy's model. Galileo observed Saturn, but was confused by the rings. He first mistook them for planets, but then those disappeared. At Saturn's equinox, its rings are in the same plane that we're observing from on Earth, so it's hard for us to see them because they're only 10 meters thick. So Galileo first saw Saturn accompanied on either side. He thought they were planets, then they disappeared, and then when he observed them in 1616, they had reappeared. So that just made him even more confused. Galileo also observed Neptune in 1612. He has it in one of his sketches, but he lost track of it before he was able to confirm that it was a planet. Neptune would later be discovered about 230 years later. Galileo also observed sunspots, another change in the heavens, another blow to the view that the heavens beyond the moon are immutable. At the time, however, many theological doctrines were based on philosophy of Aristotle. So many people assumed that Ptolemy, following in the lines of Aristotle, had to be right. Giordano Bruno was a Dominican who held that there were countless worlds around other stars and so forth. He also held some heretical doctrines and was burned at the stake in 1600. So at that time, heresy was a real risk. Galileo sent a letter in 1613 to Benedetto Castelli, arguing that heliocentrism is not contrary to biblical texts. He argued that the Bible is an authority on faith and morals, but not on science. In 1615, he expanded that previous letter 5 times longer and sent it to the Grand Duchess Christina of Florence. The same year, the Carmelite Paolo Antonio Foscarini wrote a letter to his general superior called Letter of Opinion over the Pythagorean and Copernican opinion concerning the mobility of the Earth and the stability of the Sun, which was soon banned by the Inquisition. Saint Robert Bellarmine, who was a cardinal at the time, wrote that the Copernican system could not be defended without a true physical demonstration that the sun does not circle the Earth, but the Earth circles the sun. Galileo thought his theory of the tides provided such evidence. In reality, the tides are not an effect of the Earth's motion, but just of differences in the gravitational force due to the moon and the sun. Different versions of Galileo's letter to Benedetto Castelli were flying around, and Father Niccolo Lorini got his hands on one of these versions of Galileo's letter and submitted Galileo to the Roman Inquisition for attempting to reinterpret the Bible. That was seen as a violation of the Council of Trent and also seemed like Protestantism. We can consider 1616 to be the first trial for Galileo because he went to Rome to defend himself and his ideas. The Inquisitorial Commission did not mention Galileo by name, but declared heliocentrism to be foolish and absurd in philosophy and formally heretical, since it explicitly contradicts in many places the sense of Holy Scripture. Pope Paul V asked Cardinal Bellarmine to deliver this decision to Galileo and order him to abandon heliocentrism. Copernicus's work De Revolutionibus was banned, as well as other heliocentric works. Galileo agreed to abandon heliocentrism. In reality, he probably just intended to keep it quiet. In the ensuing years, Galileo got himself into a dispute with the Jesuits. In 1618, Father Orazio Grassi, a Jesuit, published a work, The Three Comets of 1618. In this work, he argued that due to a lack of parallax, they must be beyond the moon. Galileo responded in 1619 with a discourse on comets. It was published under the name of Mario Guiducci, one of Galileo's disciples, but it was largely written by Galileo. In this work, he said the comets were a meteorological phenomenon, in the atmosphere, and the Jesuits were silly for thinking otherwise. He insulted the Jesuits a lot in this work. So Grassi replied with another work, The Astronomical and Philosophical Balance. And Galileo replied again in 1623 with Il Saggiatore, the Assayer, which is considered his scientific manifesto. The Assayer pleased Pope Urban VIII, who had just been elected that year. His name before that was Maffeo Barberini, and he was a friend of Galileo. But Galileo's The Assayer permanently alienated many Jesuits. Because Galileo's friend was now Pope, he thought he had a little bit more wiggle room with his heliocentrism, and he published a new book, Dialogue, concerning the two chief world systems, the Copernican and the Ptolemaic. Pope Urban VIII had asked Galileo to give arguments both for and against heliocentrism. But Galileo named the Aristotelian in his dialogue Simplicio, which means simpleton, and he made him seem like a fool. And because of that, the Pope was offended. Galileo was called to Rome again. He didn't reach Rome until 1633, so that's really when his second trial began. On trial, he continued to deny that he had held Copernican ideas after 1616. But Galileo was found vehemently suspect of heresy. The dialogue was banned, and Galileo was forbidden to write any future books. He was placed under house arrest in Arcetri, near Florence, until his death in 1641. Galileo was not burned at the stake. He was not tortured. Under house arrest, he continued to do science. In 1638, he described an experimental method to measure the speed of light with observers who had lanterns with shutters. But trying this at distances of less than a mile led to inconclusive results. After Galileo's death in 1718, the Inquisition's ban was partially lifted, so that in Florence, an edition of his works, except the dialogue, could be published. In 1741, Pope Benedict XIV authorized a publication of his complete works, including a mildly censored version of the dialogue. In 1758, books on heliocentrism were removed from the Index of Prohibited Books, but the dialogue and De Revolutionibus remained on the list until 1835. Then in 1939, Pope Pius XII spoke of Galileo as being among the most audacious heroes of research. In 1979, Pope John Paul II called for a new investigation of the case of Galileo, and in 1992 acknowledged that the Church had erred in condemning Galileo for asserting that the Earth revolves around the Sun. Galileo was one of the first to focus heavily on experiments and observation, which are important for the scientific method. He was also one of the first modern thinkers to clearly state that the laws of nature are mathematical. In The Essayer, he wrote, "Philosophy is written in this grand book, the universe. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures." Galileo was willing to change his views in accordance with observation. For his experiments, Galileo set up standards of length and time so that measurements made at different times and in different places could still be compared. This provided a reliable foundation on which to confirm mathematical laws using inductive reasoning. For science to progress, we need observation and experimentation. Perhaps we begin with a hypothesis, an informed prediction based on a theory. Then we conduct an experiment. We put the hypothesis to the test. Then we analyze that experiment. Are the experimental results consistent with the theory we started with? Yes or no? A scientific theory is our best explanation at present. Analysis from an experiment could corroborate a theory or strengthen it, or it could weaken it and make the case for a different theory. In science, we shouldn't say, "Oh, it's just a theory," when we mean that something is just a conjecture. Theories are our mental models that help us describe reality. Thus, the Galileo case brings us back again to discuss the relationship between science and faith. We discussed this at the very beginning of the course, but it's opportune to review here. Science is the process of using experiment, observation, and reasoning to build theories, mental models, of the natural world. Faith is the intellect's assent to the divine truth by command of the will, moved by God through grace. Because the same God who created the universe is the God of our faith, and two truths cannot contradict each other, science and faith must be in harmony. We recall that Pope John Paul II described reason and faith as the two wings upon which the human spirit rises to the contemplation of truth. Galileo recognized that science could not contradict the scriptures as long as they were rightly interpreted. It was hard at that time to change the culture to accept heliocentrism when geocentrism seemed like common sense. Galileo intuited that the Earth moves around the sun, but he did not have proof. Proof did not come until the 1800s. In 1992, John Paul II said that theologians who condemned Galileo did not recognize the formal distinction between the Bible and its interpretation. Galileo was right to point out that not all the church fathers were unanimous about how to interpret certain passages in Scripture. Passages that were discussed at this time were about the earth being firm and unchanging, It wasn't the creation account that they were disputing. It's also good to realize that Galileo's personality could have rubbed people the wrong way at the time, and that could have played a role in how the church handled him. Although Galileo was not handled in the best way, he wasn't handled in the worst way either. Nevertheless, the church has learned from this experience and continues to promote science. Good science can never contradict true faith.